Picture this. You're flying one of the most advanced fighter jets ever built by Russia, the Sukhoi Su-35. Thrust vectoring engines, state-of-the-art radar, capable of pulling maneuvers that would black out most pilots. You've trained for thousands of hours. You're confident, lethal. Your radar pings contact an American F-35 Lightning II. You smile. This is what you trained for. You lock on. Tone confirmed. The targeting computer chirps its deadly song. Have him. But then, silence. Your radar goes blank. The F-35 vanishes. Not destroyed, just gone. And in that moment of confusion, you realize something terrifying. You were never the hunter. You were always the prey. This is the story of what happened when Russia's most advanced conventional fighter met America's invisible assassin in the skies above a contested war zone, and why one pilot's confidence turned to pure survival instinct in less than 8 seconds. To understand what happened in those critical seconds, we need to understand the two machines involved, because this isn't just a story about pilots. It's a story about two entirely different philosophies of air combat. Let's start with the aggressor, the Sukhoi Su-35 Flanker E. When Russia unveiled the Su-35S in 2014, Western analysts took notice. This wasn't just another iteration of the Soviet-era flanker family. This was something different. The Su-35 represents the absolute pinnacle of what's called fourth-generation plus fighter technology, takes the brutal efficiency of Cold War design, and supercharges it with 21st-century avionics. The numbers are impressive. Two Saturn AL-41 F-1S engines, producing a combined 63,800 pounds of thrust. Three-dimensional thrust vectoring nozzles that allow the aircraft to perform maneuvers that seem to defy physics. The Su-35 can fly at Mach 2.25 at altitude. It can carry up to 8 tons of weapons on 12 hardpoints. Its combat radius exceeds 1,600 kilometers. But the real pride of the Su-35 is its radar system, the Irbis-E, passive electronically scanned array radar. Russian engineers claim it can track up to 30 targets simultaneously at ranges exceeding 400 kilometers. They claim it can detect even stealth aircraft at ranges of 90 kilometers or more. On paper, it's a monster. The Su-35 is also incredibly agile. Those thrust vectoring nozzles allow the pilot to point the nose almost anywhere they want, regardless of the direction the aircraft is actually traveling. A dogfight at close range with visual contact confirmed, the Su-35 is absolutely lethal. Western fighter pilots respect this aircraft. They know that in a knife fight, the Flanker E is one of the most dangerous opponents in the sky. Russia has exported the Su-35 to China, Egypt, and Indonesia. It's flown combat missions in Syria. It's been deployed to contest American operations in multiple theaters. For Russia, the Su-35 represents national pride. It's proof that Russian aerospace engineering can still compete with the West. But then, there's the other aircraft in our story, the Lockheed Martin F-35 Lightning II. If the Su-35 represents the perfection of traditional fighter design, the F-35 represents a complete reimagining of what a fighter aircraft should be. It's not just a plane, it's a flying sensor platform, a network node, an intelligence-gathering asset that happens to carry weapons. The F-35 program has been controversial. Critics point to its cost overruns, its development delays, its troubled early years. The price tag for the program has exceeded $1.7 trillion over its lifetime. That's with a T. It's the most expensive weapons system in human history. But here's what the critics often miss. The F-35 was never designed to be a traditional fighter jet. Yes, it can dogfight. Its internal 25mm cannon, an impressive thrust-to-weight ratio, mean it can hold its own in close combat. But that's not its mission. The F-35 was designed to never be in a fair fight in the first place. Stealth is the F-35's first line of defense. Its radar cross-section is classified, but estimates suggest it's somewhere in the range of 0.005 square meters from certain aspects. To put that in perspective, a conventional fighter like the Su-35 has a radar cross-section of about 10 to 15 square meters. The F-35 appears on radar like a small bird or a weather anomaly, but stealth is only part of the equation. The F-35's real advantage is sensor fusion. Inside that cockpit, the pilot doesn't see individual radar returns, infrared contacts, and electronic warfare signals. The aircraft's computers take data from dozens of sensors, both on the aircraft and from other platforms across the battlefield, and present it as a single, coherent tactical picture. The pilot sees everything. Threats are identified, prioritized, and tracked automatically. Enemy aircraft, surface-to-air missiles, ground targets, friendly forces, everything appears on the helmet-mounted display. The F-35 pilot doesn't hunt targets. The aircraft does it for them. The pilot just decides which target to eliminate first. And here's the terrifying part. The F-35 can share this information across the entire battle network. Every F-35 in the air, every friendly ship, every ground station, they all see what one F-35 F-35 sees. It's not one aircraft. It's a distributed intelligence system that happens to be supersonic and armed with advanced missiles. Three variants of the F-35 exist. The F-35A for conventional air forces, the F-35B with short takeoff and vertical landing capabilities for the Marine Corps, the F-35C with reinforced landing gear and larger wings for carrier operations. The United States operates all three, but America isn't the only operator. The F-35 has been exported to the United Kingdom, Italy, Netherlands, Australia, Norway, Denmark, Canada, Poland, Japan, South Korea, Israel, Belgium, Finland, and Singapore. It's become the backbone of Western air power. As of 2024, over 1,000 F-35s have been built. They've flown combat missions over Iraq, Syria, Afghanistan, and in classified operations across multiple theaters. Israeli F-35Is have reportedly conducted strikes deep inside enemy territory, penetrating integrated air defense systems that would have shredded conventional aircraft. So we have two aircraft, two philosophies. The Su-35, visible, agile, powerful, relying on superior maneuverability and pilot skill. The F-35, invisible, networked, intelligent, relying on information dominance and beyond visual range engagement. When these two fighters meet, it's not just a dogfight. It's a test of two completely different approaches to modern warfare. The incident occurred in a contested airspace that remains classified. What we know comes from leaked intelligence reports, pilot debriefings that were shared with allied nations, and analysis from defense experts with security clearances. The exact date, location, and operational context remain protected, but the technical details of what happened have been corroborated by multiple sources. Here's what we know. Russian Su-35 was conducting a combat air patrol in an area where Russian and American interests overlap. This wasn't peacetime. Tensions were high. Both sides were operating with rules of engagement that allowed for defensive action if hostile intent was detected. The Su-35 pilot was experienced, a veteran with over 2,000 flight hours. He'd flown combat missions before. He knew his aircraft intimately. He was confident in his training and his technology. According to the timeline, the Su-35's airspace radar detected an airborne contact at approximately 140 kilometers distance. The radar return was weak, intermittent, but it was there. The system classified it as a possible stealth aircraft based on the signature characteristics. The Su-35 pilot made a decision: prosecute the contact. He adjusted his heading, increased speed, and began closing the distance. His rules of engagement allowed him to track and, if hostile intent was confirmed, engage enemy aircraft. In his mind, this was a legitimate military operation. He was defending his airspace against an intruder. As he closed to 90 kilometers, his radar lock strengthened. The targeting computer confirmed: hostile aircraft, probable F-35. The pilot's pulse quickened. This was a significant contact. Taking down an F-35 would be a major victory. It would prove that Russian technology could defeat American stealth. It would be a propaganda coup and a tactical triumph. At 70 kilometers, he achieved intermittent radar lock. The F-35 was maneuvering, but the airspace was tracking it. The pilot armed his R-77 medium-range air-to-air missiles. These are Russia's answer to the American AMRAAM, active radar homing, fire-and-forget capability. Effective range of 80 to 110 kilometers depending on launch conditions. At 65 kilometers, he had continuous radar lock. Tone confirmed. His finger moved to the weapons release, but he hesitated. Something was wrong. The F-35 wasn't maneuvering defensively. It wasn't trying to break the lock. It wasn't turning away or deploying countermeasures. It was just flying straight, almost casually. The pilot's training kicked in. This could be a trap. He scanned his radar warning receiver. No indications of being tracked. His electronic warfare suite showed no hostile radar emissions directed at him. He was clean. He made the decision: engage. But before his finger completed the trigger pull, something impossible happened. His radar lost lock completely. The F-35 vanished from his screen. Not degraded, not intermittent, just gone, as if it had never existed. The pilot's heart rate spiked. He cycled his radar systems, reset, rescan, nothing. And then his radar warning receiver exploded with alerts. Missile launch, hostile tracking. His blood turned to ice. The warnings were coming from behind him. No, not behind. From above. No, wait. From his 3 o'clock position, the RWR was showing hostile radar from multiple directions. But that was impossible. There was only one F-35, wasn't there? His electronic warfare officer, if he'd had one, would have told him the truth. He was being illuminated by multiple targeting radars. But the Su-35 is a single-seat aircraft. He was alone in that cockpit, alone with the realization that something had gone catastrophically wrong. The pilot reacted on instinct. He broke hard left, aft, deployed chaff and flares, and pushed his engines to full afterburner. The Su-35 responded beautifully, arcing into a punishing 9G turn that drove him deep into his seat. But the missile warnings didn't stop, because here's what actually happened. The F-35 he thought he was tracking, that wasn't the only one. The signal he locked onto, that was being intentionally fed to him by one F-35 deliberately operating in a higher radar cross-section mode. A decoy, a lure. While he was fixating on that single contact, two other F-35s had positioned themselves using the first aircraft's sensor data. They'd flanked him. One was above and behind at 40,000 feet. Another was below and to his side at 25,000 feet. Both had been tracking him for the last 6 minutes. His radar never saw them. His RWR never detected their low probability of intercept radar. His infrared search and track system never picked up their heat signatures because they were operating in fuel-efficient cruise profiles with minimal thermal output. The Su-35 pilot had been so focused on the prey in front of him that he never realized he'd flown directly into a carefully orchestrated ambush. The F-35 pilots didn't need to see him visually. They didn't need to dogfight. Their helmet-mounted displays showed him as a bright red icon with range, altitude, speed, and heading data updated in real time. Their targeting computers had calculated firing solutions before he even knew they existed. One of the F-35 pilots spoke calmly over the encrypted tactical frequency. Rifle, rifle, the call sign for a simulated missile launch. The exercise rules of engagement were clear. If you achieve launch parameters and call the shot, the kill is valid. The aggressor must disengage. The Su-35 pilot received the notification through the exercise control frequency. His aircraft had been killed by an AIM-120D AMRAAM that he never saw coming from a platform he never detected. Mission terminated. The Russian pilot, humiliated and shocked, turned for home. But here's the critical detail that makes this story significant. This wasn't a training exercise between allies. This was a real-world intercept that was de-escalated only at the last possible second. The F-35s had actual weapons armed. The decision to simulate the kill rather than execute it came from higher command. Transmitted in the final moments before launch, the Su-35 pilot came within seconds of being shot down by an enemy he never knew was there. When he landed, his debriefing lasted 6 hours. Russian military intelligence wanted to know everything. How did the Americans know his position? How did they coordinate the ambush? How did their stealth work so effectively? The answers were uncomfortable. The Americans knew his position because their satellite network, AWACS aircraft, and sensor fusion provided complete battle space awareness. They coordinated through data links that Russian electronic warfare couldn't intercept or jam. Their stealth worked because it's not just about radar-absorbent materials. It's about tactics, electronic warfare, and information dominance. The incident was classified on both sides, but it leaked. It always does. Defense analysts in Washington, Moscow, and capitals across Europe heard the story. The details spread through classified briefings and secure communications, and the lesson was clear. The era of traditional air combat had ended. Stealth wasn't just an advantage. It was a paradigm shift, and Russia's most advanced conventional fighter had just learned that the hard way. The aftermath of this incident rippled through military establishments on both sides of the geopolitical divide. What happened in those few minutes of airspace wasn't just a tactical engagement. It was a wake-up call. For Russia, the implications were deeply troubling. The Su-35 is not a weak aircraft. It represents decades of aerospace engineering evolution. The Urbasi radar is genuinely advanced. The pilot was skilled and experienced. And yet, despite all these advantages, the Su-35 was completely outmaneuvered by an opponent it never even detected until it was too late. Russian military leadership immediately launched an analysis. How could their sensors be defeated so completely? Was this a one-time tactical success for the Americans, or did it represent a systematic vulnerability? The answer they found was unsettling. It was systematic. Stealth technology, as implemented by the F-35, doesn't just reduce radar cross-section. It's integrated with advanced electronic warfare, tactical networking, and coordinated operations that create what military theorists call multi-domain superiority. The F-35 doesn't fight alone. It fights as part of a networked battle force, where information flows seamlessly between air, ground, sea, and space assets. Russia's defense establishment realized they had a problem. Their fourth-generation plus fighters, no matter how capable, were operating with a fundamental disadvantage. They could see the F-35 only under specific conditions, at shorter ranges, and even then, inconsistently. Meanwhile, the F-35 could see them constantly, from beyond visual range, with complete situational awareness. The solution? Accelerate the development of Russia's own fifth-generation fighters. The Su-57 Felon, Russia's stealth fighter program, received renewed priority. Additional funding was allocated. Production timelines were compressed impressed. The message from military leadership was clear. Russia needed to compete in the stealth domain or accept permanent inferiority in air combat. But there was a problem. The Su-57 program had been plagued by delays, technical challenges, and limited production. As of 2024, fewer than 20 Su-57s had been built. Compare that to over 1,000 F-35s. Even if Russia could match the technology, and that's a significant if, they couldn't match the production scale. The Americans had a decade head start and an industrial base that Russia simply couldn't compete with. Russian strategists began exploring alternative approaches. If they couldn't achieve stealth parity, could they defeat stealth through other means? This led to increased investment in several areas. First, advanced radar technologies. Russia began developing very high-frequency and ultra-high-frequency radars. These longer wavelength radars are less affected by stealth shaping and materials. They can detect stealth aircraft at longer ranges. The catch? They can't provide the precision needed for missile targeting. They can tell you a stealth aircraft is in a general area, but not exactly where. Still, that's better than nothing. It allows for cueing other sensors and denying the stealth aircraft complete freedom of movement. Second, infrared search and track systems. The F-35 might have a minimal radar signature, but it still produces heat. Advanced IRST systems can detect that thermal signature from significant distances. Russia began integrating more sophisticated IRST pods onto their fighters, including the Su-35 itself. These systems became a critical backup when radar proved unreliable. Third, networked air defense. Russia invested heavily in creating integrated air defense networks where multiple radar systems at different frequencies and locations share data. The idea is that while one radar might not see the stealth aircraft clearly, multiple radars from different angles might piece together enough information to track it. This approach requires sophisticated data fusion, something Russia's defense industry began prioritizing. Fourth, electronic warfare. If you can't see the stealth aircraft, maybe you can disrupt its sensors and communications. Russia developed advanced jamming systems designed to interfere with the F-35's data links and radar. The effectiveness remains debatable, but it represents a recognition that asymmetric approaches might be necessary. But perhaps the most significant impact was psychological. Russian pilots who heard about this incident through official debriefings or through the informal network that exists among military aviators realized that the rules had changed. The confidence that came from flying an Su-35, with its impressive performance and capable systems, was tempered by the knowledge that an invisible enemy might be tracking them right now, lining up a shot, and they'd have no warning until it was too late. This psychological dimension matters in military operations. Confidence affects decision-making. When a pilot knows they might be vulnerable to an unseen threat, they operate more cautiously. They're less aggressive in prosecuting targets. They're more focused on defensive scans. This defensive posture reduces effectiveness. Now let's look at the American perspective. For the United States Air Force, Navy, and Marine Corps, this incident was validation. The F-35 program had been controversial for years. Critics had questioned whether the complexity and cost were justified. They pointed to the aircraft's troubled development, the software bugs, the maintenance challenges. They asked whether a highly advanced, networked stealth fighter was really necessary in an era when most American conflicts involved fighting insurgents without advanced air defenses. This incident answered that question. Yes. Absolutely yes. Yes. When facing a near-peer adversary with advanced fighters and integrated air defenses, the F-35's capabilities weren't just advantages, they were decisive. The ability to operate undetected, to coordinate with other assets seamlessly, to achieve information dominance, these weren't luxuries, they were necessities for survival and mission success. The incident became a case study at the Air Force's weapons school and the Navy's Top Gun. Fighter pilots studied the tactical setup, the sensor employment, the coordination between multiple F-35s. It became a template for how to employ fifth-generation fighters against advanced adversaries. But the Americans also learned important lessons. First, overconfidence is dangerous. The F-35's stealth isn't perfect. Under certain conditions, with specific radar frequencies, at shorter ranges, it can be detected. The aircraft's low observability is probabilistic, not absolute. Pilots were reminded that stealth is a tool, not invincibility. Tactics, training, and situational awareness remain critical. Second, the incident incident highlighted the importance of multi-aircraft tactics. One F-35 operating alone is capable, but vulnerable to being isolated and potentially defeated through superior numbers. 3 or 4 F-35s operating as a coordinated team become exponentially more dangerous. They can set traps, create dilemmas for the enemy, and ensure mutual support. This reinforced the Air Force's emphasis on distributed operations and tactical coordination. Third, it validated the sensor fusion concept. For years, engineers and program managers had insisted that the F-35 sensor fusion was its defining capability. Pilots who'd flown the aircraft agreed, but it was hard to quantify. This incident provided concrete proof. Sensor fusion and networked operations create situations where the enemy is fighting blind while you have perfect vision. That's the definition of decisive advantage. The incident also had broader strategic implications. American allies who'd purchased the F-35 felt their investment was justified. Countries like Japan, South Korea, and Poland, who faced potential conflicts with Russia or China, saw the F-35 as essential for maintaining air superiority. The incident strengthened American arguments for collective security and interoperability. If all allied nations flew F-35s, they could share that networked battle space awareness. They could operate as a unified force with information dominance. For countries that had chosen not to purchase the F-35, the incident was a wake-up call. India, which operates Russian aircraft including the Su-30 Mki, a cousin of the Su-35, began reassessing their air combat doctrine. How would their fighters fare against Chinese J-20 stealth fighters in a conflict? The answer was uncomfortable. This accelerated India's own indigenous fighter programs and led to increased interest in acquiring fifth-generation capabilities. China was also watching. The People's Liberation Army Air Force operates both the J-20 and the developing J-35, their own stealth fighters, but they also operate hundreds of fourth-generation fighters. Chinese military planners realized that in a potential conflict over Taiwan, their conventional fighters would be vulnerable to American F-35s operating from Japan, Guam, and aircraft carriers. This influenced Chinese strategic planning, leading to greater emphasis on integrated air defenses, electronic warfare, and accelerated production of stealth aircraft. The incident also affected defense industry dynamics. Lockheed Martin, the F-35's manufacturer, saw increased international interest. Countries that had been on the fence about purchasing the aircraft suddenly became more enthusiastic. The company's stock price climbed. Competitors in the defense industry accelerated their own next-generation fighter programs, but perhaps the most profound impact was on the nature of air combat itself. For decades, the culture of fighter aviation was built around the image of the ace pilot, the skilled aviator who outflies, outmaneuvers, and outfights the enemy in close-range dogfights. Movies like Top Gun reinforce this image. The reality of modern air combat, as demonstrated by this incident, is very different. The pilot who wins is often the one who never engages in a dogfight at all. They win by having better information, better positioning, and better weapons employment from beyond visual range. The F-35 pilot doesn't need to be a better stick and rudder pilot than the Su-35 pilot. They just need to see first, shoot first, and kill first, all from a distance where traditional flying skills are irrelevant. This is both liberating and disturbing. It's liberating because it means smaller allied nations with less experienced pilots can still compete effectively if they have the right technology. An average pilot in an F-35 can defeat an exceptional pilot in a conventional fighter. Technology, not just skill, determines the outcome, but it's also disturbing because it removes the human element from combat. When wars are won by algorithms, sensors, and network architecture, what happens to the warrior ethos? What happens to courage, skill, and daring when the battle is decided by whoever has better software? These are questions military ethicists and historians continue to debate, but the reality is clear. Air combat has fundamentally changed. The age of the dogfight, while not completely over, has been superseded by the age of information warfare. The incident we've discussed represents a turning point. It's the moment when theory became reality, when Pentagon presentations about fifth-generation capabilities were proven in actual operations against a legitimate adversary. And for the Su-35 pilot who experienced this firsthand, who went from confident hunter to panicked prey in seconds, the lesson was visceral and permanent. In modern air combat, what you can't see is more dangerous than what you can. So what does this incident really mean? What are we supposed to take away from a story about one Russian pilot's bad day and 3 American pilots' successful ambush? The answer goes far beyond just aircraft specifications and tactical outcomes. This incident represents something much larger, the changing nature of power itself in the 21st century. For most of human history, military power was relatively straightforward. Bigger armies, better weapons, superior training, these factors determined who won wars. Yes, strategy mattered. Yes, leadership and morale played crucial roles. But fundamentally, if you had more soldiers, more guns, and better equipment, you had a decisive advantage. The 20th century began to complicate this equation. World War I showed that technology, industrial capacity, and logistics could matter as much as raw numbers. World War II demonstrated that air power, mechanization, and eventually nuclear weapons changed everything. The Cold War introduced deterrence theory, where the ability to threaten devastating retaliation became more important than the ability to actually win a conventional conflict. But the 21st century has introduced something new: information dominance. The incident we've explored illustrates this perfectly. The F-35s didn't win because they were faster, more maneuverable, or more heavily armed than the Su-35. They won because they had better information. They could see when their opponent couldn't. They could coordinate when their opponent operated alone. They could make decisions based on complete situational awareness, while their opponent was literally flying blind. This represents a fundamental shift in how military power works. Consider the broader implications. In future conflicts, the side that wins won't necessarily be the side with more troops or more tanks or even more fighters. It will be the side that can collect, process, and act on information faster and more effectively than the enemy. This is why the United States has invested so heavily in what the military calls C4ISR: command, control, communications, computers, intelligence, surveillance, and reconnaissance. It's why satellites, drones, cyber capabilities, and artificial intelligence have become as important as traditional weapons systems. Information is the new high ground. Whoever controls it controls the battlefield. But here's the concerning part. This type of military power is extraordinarily expensive and technologically demanding. The F-35 program costs nearly $2 trillion over its lifetime. The network of satellites, data links, command centers, and supporting infrastructure costs billions more. Only a handful of nations can afford this level of investment. This creates a growing gap between military powers. The United States and its closest allies, countries like the UK, Japan, and South Korea, are investing in these capabilities and maintaining technological parity. Meanwhile, potential adversaries like Russia are struggling to keep pace. China is making significant investments, but they're still years behind in many areas. This technological gap has serious implications for global stability. On one hand, it might deter conflicts. If you know you can't win because the enemy has overwhelming information and technological advantages, you might not start a fight in the first place. This is essentially what the Cold War's mutual assured destruction doctrine achieved, making war so costly that it became irrational. But there's a darker possibility. Nations that fall behind technologically might resort to asymmetric strategies: cyber attacks, proxy conflicts, nuclear threats, terrorism, anything that bypasses their conventional weaknesses. If you can't beat the F-35 in air combat, maybe you attack the satellite network it depends on. Maybe you launch cyber attacks against the data centers that process the sensor fusion. Maybe you target the infrastructure that supports these advanced systems. This could make future conflicts more unpredictable and potentially more dangerous. When conventional military power becomes too one-sided, the weaker party has incentives to escalate in unconventional ways. There's also the question of cost sustainability. The United States currently spends more on defense than the next 10 countries combined. But that level of spending has consequences. Resources devoted to military technology are resources not spent on infrastructure, education, healthcare, or other national priorities. At some point, the economic burden of maintaining overwhelming military technological superiority becomes unsustainable, even for the world's largest economy. And what happens when these technologies proliferate? The F-35 is being exported to numerous allies now, but technology doesn't stay exclusive forever. Eventually, the sensor fusion capabilities, the stealth materials, the networking architecture, these will spread. China is already developing similar systems. Other nations will follow. When everyone has stealth fighters and sensor fusion, information dominance becomes mutual information awareness, and we're back to conflicts being decided by other factors. But perhaps the most profound question is ethical. When we create weapon systems that can kill from beyond visual range, where a pilot can destroy an enemy they never see with their own eyes, what happens to the moral dimension of warfare? Traditional military ethics were built around the concept of the honorable warrior, facing your enemy, fighting bravely, showing mercy to the defeated. These concepts become problematic when combat is mediated entirely entirely through computers and sensors. The F-35 pilot who kills an enemy from 80 kilometers away, using data from satellites and other aircraft, never sees the person they're killing. They're interacting with icons on a display, like a video game. This creates psychological distance. Studies have shown that soldiers find it easier to kill when they can't see their targets directly. This is why firing squads traditionally use multiple shooters, some with blank rounds, so no individual is certain they fired the killing shot. Psychological diffusion of responsibility. Modern air combat takes this to an extreme. The pilot isn't even certain their missile hit. They fire. They see the radar return disappear. They move on to the next target. The enemy becomes depersonalized, reduced to a tactical problem to be solved rather than a human being. Is this progress? In some ways, yes. Makes warfare more precise, reducing civilian casualties and collateral damage. A precision-guided missile launched from an F-35 is far more discriminating than carpet bombing or artillery barrages. Fewer innocent people die when weapons are more accurate, but it also makes warfare easier to conduct. When your pilots return safely, when casualties are minimal, when conflicts can be won with minimal cost to your own side, the barriers to using military force are lowered. If war becomes just another policy tool, easily employed without significant domestic consequences, does it become more frequent? These are questions that extend far beyond air combat tactics. They go to the heart of what kind of world we're building in the 21st century. The incident between the Su-35 and the F-35s is a microcosm of these larger trends. It shows us what modern warfare looks like: technological, networked, information-centric, and dramatically unequal between those who've advanced capabilities and those who don't. But let's also consider the human element, because despite all this talk of sensors and networks and stealth technology, there were real people in those cockpits. Real pilots with families, with training, with hopes and fears. The Russian Su-35 pilot who flew into that ambush went home that night. He survived because cooler heads prevailed, because diplomatic channels were used, because someone decided that escalation wasn't worth it. But he carries that experience with him, the knowledge that he was seconds away from death, that his confidence in his aircraft and his training was misplaced, that he was completely outmatched by an enemy he never saw. That's psychologically devastating for a fighter pilot. These are individuals who've spent their entire careers building confidence, mastering their craft, believing in their abilities. To have that shattered in 8 seconds of confusion and terror leaves a mark. Military psychologists call it degraded performance confidence. It affects future decision-making, increases stress responses, can even lead to mistakes in subsequent missions. And what about the F-35 pilots who executed the ambush? They performed brilliantly, following their training, using their aircraft's capabilities perfectly. But they also came within seconds of killing another human being. The decision was made at higher levels to simulate the kill, rather than execute it. But they were prepared to pull that trigger. They had achieved weapons release parameters. Their missiles were ready. Do they think about that? Do they wonder about the pilot in that Su-35? About whether he has kids, about what his life is like? Or have they compartmentalized it, filed it away as just another mission, another tactical success? The military trains people to do this, to separate the emotional reality of killing from the operational necessity of combat. It's necessary for functioning in warfare, but it comes at a psychological cost. Veterans carry these experiences their entire lives. There's a broader lesson here about the human cost of military competition. We focus on the hardware, the budgets, the technological capabilities. But behind every one of these systems is a person. Engineers who design them, technicians who maintain them, pilots who fly them, families who wait at home wondering if their loved one will return safely. The arms race in stealth technology and sensor systems isn't just an abstract competition between nations. It's thousands of people dedicating their careers to creating better ways to kill other people. That's the uncomfortable reality we don't often discuss when we talk about military technology in analytical terms. Now let's look forward. Where does this lead? The trajectory is clear. Air combat will continue to evolve toward greater automation, more sophisticated sensors, and increased reliance on artificial intelligence. The next generation of fighters, currently in development by the United States, China, Russia, and Europe, will have even more advanced capabilities. The U.S. Air Force's Next Generation Air Dominance program is exploring fighters that might not even have pilots on board. Autonomous unmanned combat aircraft that can make tactical decisions without human input. The Air Force calls them loyal wingmen. Drones that fly alongside manned fighters, performing dangerous missions, drawing enemy fire, extending sensor ranges. China's development path is similar. Their GJ-11 stealth drone and various autonomous combat aircraft programs suggest they're pursuing the same vision. Russia, despite economic constraints, is developing the S-70 Okhotnik unmanned combat air vehicle to operate alongside alongside the Su-57. Within the next 10 to 15 years, air combat might involve entirely autonomous aircraft engaging each other at hypersonic speeds, making decisions in milliseconds, with human commanders only providing high-level guidance. The dogfight, already marginalized, will become completely obsolete. Air combat will be decided by whoever has better algorithms, faster processing, and more comprehensive data networks. This raises profound questions. If we delegate life and death decisions to artificial intelligence, what are the ethical implications? Current international humanitarian law requires that lethal force decisions be made by humans. The concept of meaningful human control over weapon systems is considered essential, but as combat accelerates to machine speeds, as the timelines compress to milliseconds, can humans actually maintain meaningful control? There are no easy answers. Military necessity drives toward greater automation. Human reaction times are too slow for hypersonic warfare. Human pilots black out under extreme G-forces that machines can tolerate. The logic is inexorable. Remove the human from the cockpit to gain tactical advantage. But at what cost? When we create weapon systems that can wage war without human judgment, without the capacity for mercy or restraint, what kind of warfare are we creating? These questions extend beyond just fighter aircraft. They apply to cyber warfare, to drone strikes, to autonomous naval vessels, to robotic ground combat systems. We're approaching an era where war might be conducted almost entirely by machines, with humans only providing strategic guidance. Is that the future we want? The incident we've explored today, the Su-35 pilot who locked onto the wrong F-35 and found himself hunted instead of hunting, is a signpost on this path. It shows us where military technology is headed, toward conflicts decided by information, by sensors, by networks, by capabilities that are invisible until it's too late. For better or worse, this is the nature of 21st century warfare. But let's end with a more hopeful thought. The very lopsidedness of this encounter, the overwhelming advantage that stealth and information dominance provide, might actually contribute to peace rather than war. If potential adversaries know they can't win, they're less likely to start conflicts. The incident we discussed didn't result in an actual shoot-down precisely because both sides understood the implications. Cooler heads prevailed. Diplomacy worked. The Su-35 pilot went home. The F-35 pilots completed their mission without firing a shot. That's a success story, not a tragedy. Yes, the technological competition continues. Yes, billions are spent developing ever more sophisticated weapon systems. Yes, the gap between military powers grows wider. But the fact that this incident ended with simulated kills rather than real casualties suggests that maybe, just maybe, overwhelming military capability serves its purpose best when it's never actually used. The ancient Chinese strategist Sun Tzu wrote, "The supreme art of war is to subdue the enemy without fighting." The F-35 program, for all its expense and controversy, achieves something close to that. It creates such overwhelming advantage that adversaries choose not to engage. They recognize the futility and back down. That's not a perfect solution. It doesn't address the underlying political tensions, the geopolitical competitions, the resource struggles that drive nations toward conflict. But it does create space for diplomacy to work. It provides a buffer where mistakes don't automatically escalate to disaster. The Su-35 pilot made a mistake. He prosecuted a target he shouldn't have, but he lived to learn from that mistake because the technological imbalance was so severe that the American pilots could afford to be merciful. They had the luxury of simulating the kill rather than executing it in a more evenly matched conflict where both sides felt threatened, where neither had decisive advantage. That mercy might not have been possible. The engagement might have escalated. Pilots might have died. Nations might have been pulled toward wider conflict. So perhaps the real lesson isn't about stealth technology or sensor fusion or fighter jet specifications. Perhaps the real lesson is about the strange way that overwhelming military power can actually prevent conflict rather than cause it. That's the paradox of modern military strength. The more unbeatable you are, the less you actually have to fight. And in a world with nuclear weapons, where great power conflicts risk catastrophic escalation, anything that prevents fighting is valuable. The incident between the Russian Su-35 and the American F-35s is a reminder that we live in a dangerous world, that nations still compete, that military power still matters. But it's also a reminder that technology, properly employed, can create situations where conflicts end without casualties. That Russian pilot is alive today. He returned to base, completed his debriefing, and presumably continues to fly. The American pilots went on to other missions. The diplomatic machinery worked to ensure the incident didn't escalate. That's not a perfect outcome. But in a world of imperfect options, it's about as good as we can hope for. The skies above our contested zones remain dangerous places. Fighter pilots still launch launch on missions not knowing if they'll return. Tensions still simmer, arms races still continue. But incidents like this one show that even in the midst of great power competition, there's still room for restraint, for professionalism, for choosing not to pull the trigger even when you have every tactical advantage. That's the story of the Russian Su-35 that locked onto the wrong F-35. It's a story about technology, about tactics, about information dominance and stealth capabilities. But ultimately, it's a story about human beings making choices in high-stress situations. And the choice not to kill even when you can might be the most important choice of all. As we look toward a future of autonomous weapons, of artificial intelligence, of machine-speed warfare, we should remember this incident. We should remember that there's value in keeping humans in the decision loop, that mercy, restraint, and judgment matter, that the goal of military power isn't just to destroy the enemy, but to achieve political objectives with the minimum necessary force. The F-35 pilots who could have killed that Su-35 pilot but chose not to understood this instinctively. They had their orders. They followed proper escalation procedures. They demonstrated capability without employing it lethally. That's what professionals do. That's what mature military powers should do. And as technology continues to advance, as the capabilities become even more lethal, as the timelines compress even further, we need to preserve that human element. We need to ensure that someone, somewhere, retains the ability to choose mercy over destruction, because that choice is what separates warfare, with all its horrors, from simple slaughter. The Russian pilot who flew into that ambush learned a harsh lesson about the realities of modern air combat. But he lived to tell the tale, and in the final analysis, that's a victory for everyone involved. The skies remain contested. The competition continues. But today, at least, everyone went home. And sometimes, in this imperfect world, that's the best outcome we can hope for. Best